Okay, so welcome to 9.5. Today we're going to try and talk about what happens when your conics contain this extra, or your conic general forms contain this extra term right here. So remember how we talked about conics being written in general format? You can write all conics like this, but normally they don't have that bxy there. See that guy? So today B is for bully, because when you see a bxy term, that guy will take your entire conic and tilt it. Let me just show you. This is a typical graph of a conic that had a bully in it. See how it's tilted? Come on. Everybody see it? All right, thank you. It turns out that it's actually the same as this one. See, the blue one is non-tilted. The blue one is just really a simple conic. It's actually just x squared over 4 plus y squared over 20 equals 1. It's no big deal. But once it's been tilted, the equation looks different, and the graph is obviously tilted. So what I'm saying is this can be easily multiplied out. If you multiply by 80, you get 20x squared plus 4y squared equals 80, right? Then you can divide by 4 or something. So you get like 5x squared plus y squared equals 20, right? That's just a real simple standard form. There's no bully in it. There's no bxy, okay? But the other equation, this red one, well, that one's different. That one has the b in it, and it might be an equation like, for example, might be this equation. Right here, or something. Okay? So it might look more like this. And by the way, once we get the bully term in there, it is impossible to put it back into standard form. Okay? So you don't have to write anything down quite yet, but just know that if there's a bully in the formula, not only does he tilt the conic, which makes life harder for graphing, but he also makes it impossible to put into standard form. In other words, there's no magic numbers you can add to complete the square. And it's this guy's fault. So that's why I'm calling him the bully today. He keeps us from writing standard form. He tilts our graphs to make them harder to draw. Okay? So one of our big objectives today is to learn to eliminate the bully from the problem so we can properly sketch it. Okay? So that's what we're trying to do. So that's a real general overview of what we're trying to do. Now, before we can do any new skills at all, we need to kind of talk about some old skills real quick. We already discussed this earlier, I think. It wasn't in the book so far, but I put it in the notes. You might remember me saying something like, the reason we know this right here is an ellipse, in example 1a, the reason we know that's an ellipse is because the A is 3 and the C is 6, and those have the same sign. Didn't we mention that before? Okay. So since A and C both have the same sign, automatically that makes it an ellipse. Okay, there's another way to say that too. It says here it's going to be an ellipse if AC is positive. A times C is positive. So you have to admit, this really does mean the same thing. Because if I told you A times C was a positive number, one thing you would know for sure is that both A and C are positive numbers or negative numbers. In other words, A times C can only be positive if A and C are both positive or A and C are both negative. Okay, so here's a nicer way to say what I said a week ago. I said it will be an ellipse when A and C have the same sign. Today we can say it a little more mathy-like and say if A times C is positive, it'll be an ellipse. It means the same thing. It means A and C have the same sign. Okay, look at example 1b. Do you guys recognize what kind of conic this would be? Hyperbola is correct. And it's really because the A is 2 and the C is negative 3, and that's all you really need to know. You need to know that the quadratic coefficients have opposite signs. So when they have opposite signs, or when you multiply them together and you get a negative, that's proof pretty much that it's a hyperbola. Okay? On this next problem, part C, you guys could probably tell right away by looking at it. Parabola. And that's because x squared is missing, right? Okay, so we would say that capital A is 0, capital C is 1. By the way, capital C is the coefficient of your y squared, so that's why I'm saying it's 1. So A is missing from the problem. There is no x squared. And then there's a 1y squared, so C is 1. So you would just say, oh yeah, I'm missing a term, or capital A is 0. Okay, in other words, A times C is 0 proves that either A was 0 or C was 0, and it's missing from the problem. So yes, you're right, this is a parabola. So these are just some old rules. We're just revisiting them and sort of rewording them. We were saying that it's going to be a parabola if A times C is 0. It's going to be an ellipse if AC is positive. It's going to be hyperbola if AC is negative. That's not new. It's just a nicer way to say what I said a week ago. Okay, now, I'd like you to flip to page 5 in your notes. Okay. Scroll down, scroll down. It's the last thing in your notes. And mine's kind of split between pages, but yours shouldn't be. And I don't know if it says example 3. Yeah, it says example 3. It's really example 5. But the point is I wanted to do this now, and this should say ABC on my notes. I think yours says ABC, right? Yeah. Okay, so this is a little different now. Now the bully is in the problem. B is for bully. So if you look closely, these problems are a little different because, actually they're very different because of this guy. Okay? So because the bully just showed up, that changes the game completely. Okay? Just the same way a bully can change the way you walk to school. Right? If there's a bully on the way, you might check your path. But when there's a bully in the equation, it totally changes how we identify the conic. Okay? So you may no longer use what I just showed you. You may not use the rules on page 1 if there's a bully in the problem. Here's what you have to do. You have to find b squared minus 4ac. Okay? And if it's 0, it's a parabola. If it's negative, it's an ellipse. And if it's positive, it's a hyperbola. Very different rules for the bully problems. Okay, so without further ado, let's look at this example. It's really example 5. I could tell you right now what kind of conic this is. Now, the naive student would just look at this thing, just like take a quick glance at it. They would say, oh yeah, A is 8, oh yeah, C is 17, that's an ellipse. Same sign, 8, 17. But it might not be an ellipse. We have to be really, really careful. Because the bully's in the problem, we cannot use that old logic. We have to use the new logic. So don't just write down A and C. You also need to write down B. And don't just look at A and C. Look at A, B, and C. Find this, in fact. This is called a discriminant. In the past, we've seen it. It will help us decide how many positive roots, or how many real roots a quadratic equation has. Now the discriminant's job is to tell us what kind of conic we're dealing with. Okay, so we'll plug in the negative 12 minus 4 times 8 times 17. And this gives us, I think it's 144 minus 544. I checked earlier. I got negative 400, but it doesn't really matter that I got negative 400. It matters that I got a negative. Okay, so it turns out this really was an ellipse after all. Okay, it's an ellipse. Is it because A and C had the same side? No. No, it's because b squared minus 4ac was negative. Let's do an example 3b. It's not in your notes, but we're going to add it on real quick. So that one came out negative. That's an ellipse. Let's try this one now, part B. How about 4x squared minus 4xy plus y squared minus 2x minus y equals 0. See, at first glance, a student would just say, oh yeah, A is 4, C is 1. Ellipse. Turns out this is not an ellipse. You you got tricked by the bully. Okay, so turns out there's a bully term, so watch out for that. Find b squared minus 4ac. There is no other way. B squared minus 4ac. Ooh, 16 minus 16 is 0. I guess it's actually a parabola. You might say, what? How could that be a parabola? It's got an x squared and a y squared. Exactly. The bully is there to confuse you. Tilted parabolas do have both an x squared and a y squared. Okay? So here's the thing. There's two sets of rules. If there's a bully, you use the rules on page 5. If there's no bully, you can use the rules on page 1. Can anybody think of a way to simplify our lives so we don't have to memorize two different sets of rules for two different situations? So I'll pause the recording and you can answer that. Okay, so you guys are right. We are going to throw away the rules on page 1. We're only going to use the b squared minus 4ac trick. If there happens to be no b, we'll just use b equals 0. So let's go back to page 1 now and redo those examples using the rules on page 5 instead. Okay, so here we go. So A is 3 and B is missing. There's no bully. And C is 6. B squared minus 4AC is 0 squared minus 4 times 3 times 6, which is clearly negative. Ellipse. I just got ellipse for example 1A. Is that what I had before? Yes. Okay, it worked. It worked. Okay, let's try example 1B. I'll do that one in red. So in example 1B, A is 2 and B is missing and C is negative 3. So my B is 0. So then I do my B squared minus 4AC trick. And we have 0 squared minus 4 times 2 times negative 3. And that's basically just 24, which is positive. And we just showed this was a hyperbola. Is that what we had decided before? Example 1b, was it hyperbola earlier? Yes. Okay. So if you're going to use the rules on page 1, know that you can only use them when there's no bully. You'll need the rules on page 5 when there's a bully. If you throw away the rules on page 1, you can always use the b squared minus 4ac trick, which is obviously the wiser thing to do. Okay, we won't do part C again. All right, let's go now to our next topic. So the bully has a way of distracting us and confusing us so we don't recognize quickly the general form. Nobody looks at a general form like this and says, oh yeah, that's a hyperbola. You can't do that anymore. You've got to do b squared minus 4ac. Okay? All right. You don't have this page, sorry. The other thing it does is it twists the graph. I mentioned that earlier. It takes our graph and it turns it in space. It ruins the standard form also. So graphing more complicated, identifying more complicated. So how exactly does the twisting work? So it turns out, this is a little bit hard to understand. It turns out if you have a happy face, right? And then somebody wants to rotate it, like this, right? The coordinates of every single point are going to change, with the exception of the actual points that are on the circle of rotation. So if this is a perfectly circular head, obviously the points on the rim of the circle aren't moving, but everything else inside that, 2 eyeballs in the mouth are, right? If it's a hyperbola or something, watch close. Let's say you have a hyperbola like this. Right, and somebody wants to move it, every point moves. The only point that's stationary in space right now is the center of rotation, but obviously, you can see if I'm turning, that point's the only one that's not literally moving on the paper. Right? Okay, so because of that, because we often have x and y axes, this gets very complicated because look, the coordinates of every point are going to change. I don't know why you guys are sleeping. Like, this is a horrible day to sleep. The most complicated lesson of the year. When these turn, only the red point stays put, right? But all the points are moving around. We have to write a mapping of where they will be, right? So that whole b BXY equation, those equations tell you exactly where every point goes. The problem is we don't recognize them. Like, we can't just look at one of these and say, oh yeah, that's an ellipse, and I can put it in standard form and tell you little a and tell you little b and find the foci. You can't do any of that because the bully's in the way, and you can't get it in standard form. So you can't sketch it. You can't figure out where foci are. You can't even tell me what little a and little b are until it's in standard form, right? See the problem? Okay, so we have to find a way to eliminate the bully. Or another way of saying it is we have to find a way, if we are given a tilted conic, let's say like this, okay, we need to find a way to tilt our axes. We need to tilt our axes. This is like a trick we're going to try. Hold on. We're going to tilt the axes like this. You see? My point. This point's not the right place anymore. Okay, we're going to tilt our axes until it lines up with the rotated conic. Then we'll write the standard form. Because it won't be tilted anymore because we tilted our axes. And after we get to standard form, we can analyze the foci and all that stuff. So that's the goal. We're going to take our tilted shapes, and we're going to tilt our axes to match up nicely with the tilted shape, write the equation in standard form with our new axes, and then we'll be able to measure it and do anything we want with it. Okay, so this is obviously going to be extremely complicated. Okay, so going back to the notes. How does it transform? Well, it turns out that x and y are the old variables, but they're going to be replaced with these new variables. So all the old x's are going to be replaced with x prime cos theta plus or minus y prime sin theta. And all the old y's are going to be replaced with basically almost the same thing, but it's x prime sin theta plus y prime cos theta. I don't have time to go into this right now because if I try to explain to you why this is happening, I would have to teach you matrices, matrix multiplication, and there isn't time for that. And also matrices is chapter 10. So we're just going to take these two formulas as a gift. They're on a silver platter. Let's use them all we want without understanding them today. Maybe by the end of the year you'll understand them better. Okay, so here's an example. Did you ever stop to think that this equation, this is a very familiar equation here. Let me show you. I'm sure you recognize this little equation here. Y equals 1 over x. Did you ever notice that this is hyperbola? Did you ever think about that? This is a very familiar graph. This is one of our top 10. It made it to the wall of fame. It's right here. Did you ever stop to think that that's a hyperbola? Isn't it? It's hyperbola. It's a slice off a cone, actually. Okay? And it's got foci. In fact, this morning I added my foci points together. Interesting problem, like, hey, find the foci of the hyperbola. Y equals 1 over x. Well, I guess they're here and here, but where are the coordinates? Well, it turns out they're at rad 2 over 2. I'm sorry, they're at rad 2, comma, rad 2, comma, negative rad 2, negative rad 2. How do we know that? Well, because this, if you draw your axes this way, this is just the hyperbola x squared over 2 minus y squared over 2 equals 1. And the a and b values are both rad 2. The a squared is 2. The b squared is 2. Now I'm using the tilted axes now. I'm not using the black axis. I'm using the blue axes. But if you tilt your head and you tilt the axes to match the hyperbola, it's this hyperbola. Using the new axes. And it's a very simple thing to show that the c value is 2, because it's just 2 plus 2 is 4. So c squared is a squared plus b squared, remember? So it would be 2 plus 2, which is 4. So c squared is 4, c is 2. So in other words, this distance is 2 right here. I'll highlight it in green. This distance is 2. Right there. And therefore, when we erase the axes, give me 1 second, clean this up, or I can just push clear ink. There we go. If this distance is 2, then going back to the world of traditional x and y, where x is horizontal and y is vertical, this forms a Pythagorean triangle, or I should say 45, 45, 90 triangle, where this is 2 over root 2, and this is 2 over root 2. In other words, this is root 2, and this is root 2. Like I said, the coordinates were root 2, root 2. When you switch back to rectangular. Okay, it's crazy. I heard that whisper. It's crazy. So we're not going to actually analyze this problem too deeply, but the point is, even y equals 1 over x is a hyperbola with foci, but the problem is, the foci are hard to find because somebody tilted the graph, you see, and it turns out it's actually a perfect 45-degree tilt. And when I drew those new axes, you have to admit, if we're using this as our x-axis, and this is our y-axis, this is not really tilted anymore because we tilted the axis to match it. It's just a simple x squared minus y squared style hyperbola. Okay? Okay, so we have a question on the table. Okay, so the question just came up. How did Mr. Shore know that when you tilt this and make this your x and y axes, how did I know that this was the hyperbola x squared over 2 minus y squared over 2 equals 1? How did I know that? And the answer is I use these substitutions right here in your notes. Okay? All right, so let me show you how I got it. That's actually what this problem is all about. It says express the equation xy equals 1. That just means y equals 1 over x. Express the equation xy equals 1 in terms of the new x prime y prime coordinates by rotating the axes through a 45-degree angle. So in other words, theta is going to be 45. X is going to be changed over to x prime cos 45 minus y prime sine 45. Y is going to change to x prime sine 45 plus y prime cos 45. Okay? It's going to produce a new equation. So the old x is now x prime cos 45 minus y prime sine 45. The old y is now x prime sine 45 plus y prime cos 45. And this is equal to 1. This is the old equation, x, y equals 1. I just updated it into modern tilted language. Okay? So that's our new x, that's our new y. Okay, isn't Mr. Shore wrote cos y? Mr. Shore meant to write cos 45, obviously. Isn't cosine 45 and sine 45 both root 2 over 2? They're both root 2 over 2, right? Okay, so Mr. Shore is going to pull out a root 2 over 2 here. And he's going to pull out a root 2 over 2 here. And what's root 2 over 2 times root 2 over 2? So what do you get when you multiply the rad 2's together? Not 2. Rad 4 over 4 is? 2 over 4 is? 1/2. Okay, so those guys become halfer. Okay. And we get x prime squared minus y prime squared equals 1. So this is how Mr. Shore knew that it was x squared over 2 minus y squared over 2 equals 1. Now there's some primes in here. You see these little apostrophes? They just mean that they mean that the x is measured and the y is measured in the new tilted axes. That's all it means. So if you don't want to write the primes, that's fine. That's okay. These little apostrophes, you can stop writing those if you want. Just know that your final equation is based on the tilted axes. So like when I say x equals 1, right? When Mr. Shore says x equals 1, I don't mean like right 1. I mean this way 1. So this is technically called x prime axis, and this is called the y prime axis. But if you're doing your measuring along the blues, You can just think of it as x equals 1. But it really means along that direction. All right, so pretty complicated stuff. But that's how I knew that a squared was 2 and b squared was 2. Eventually we proved that c is 2, and I was able to find a full sine everything. Okay, so this problem's kind of an interesting one. But see the bully? The bully was in this problem. See? Anytime you see an xy right there, that's a bully. He's going to tilt the graph. So this is just the simplest of all the bully problems I could think of. Okay, now let's go to our next page, or our next idea. Now, if there's a bully in the function, right, he's going to turn the graph, which makes the graphing harder. He's going to turn the graph, which ruins our standard form. We did see a way to substitute x and y so that we could retrieve standard form. That's cool. But it'd be nice to know how much influence the bully really has. What I mean is, just how much is the bully tilting the graph? Okay? So this guy right here has a job in life. He's a bully analyst. His job is to determine just how twisted the graph really is. So this will calculate an angle, or calculates the angle of tilt. Think of it that way. It calculates the angle of tilt. And he's very specifically designed so that you always get a positive counterclockwise of tilt that's acute. In other words, your answers will always, always, always come out like this. Positive and acute. Positive meaning greater than 0, acute meaning less than 90. Wonderful. So this is a great little bully analyst, and that's his job. He'll tell you how much tilt is going on. Just using A, B, and C. So we use b squared minus 4ac to figure out what kind of conic it is. We use cot 2 theta equals a minus c over b to figure out just how tilted our conic is. All right? All right, now let's go to this real example. It says example 3. This is the real example 3. And this sucker is going to take us forever. All right? So give yourself a lot of space and be very patient. Okay, first things first. Let's see if we can figure out what kind of conic we think it is. Okay, so we have a little trick for that. What is A? What is B? What is C? Jot those down, plug them in, and tell me what kind of conic it is, okay? Okay, so you guys figured out it's an ellipse because you chose A is 1, B is rad 3, C is 2. So you have rad 3 squared minus 4 times 1 times 2. So this just comes out to 3 minus 8, which is clearly negative. So yeah, you guys are right, it's an ellipse. Okay, now it's time to find the tilt angle. So let's use our bully discriminator, or our bully analyzer. We should be able to figure out the tilt angle on that ellipse. Okay, so you should have plugged in 1 minus 2 over rad 3. So you should have had negative root 3 over 3. Raise your hand if that's what you had. Okay, that's good. Most of us aren't real comfortable working with cot, okay? But just think of it as x over y. So you've got a unit circle there in your binder, right? You're looking for a point. It's probably the 150 or the 120, right? And then you're trying to make sure that the x divided by the y, is negative root 3 over 3. So the x divided by the y is negative root 3 over 3. So which one is it? Is it the 120 or is it the 150? It turns out it's the 120. Okay, it's not the 150. If it was the 150, 150 has a cot negative root 3 over 2 over half. So that would be negative rad 3 over 1, not negative rad 3 over 3. So it turns out it's the 120, not the 150. So that might take you a little while to figure out. Okay, so it's not the 150, it's 120. This is 2 theta. Okay? So what does this tell us about theta? 60. Okay, so far we haven't solved this problem, but we figured out 2 things. Somebody has tilted our ellipse by 60 degrees. That's what we've learned. Okay, now, here's what we're going to do. Now that we know that our ellipse is tilted by by 60 degrees. What we're going to do is we're going to tilt our axes by 60 degrees. We're going to tilt our axes 60 degrees to create a new axis system of measurement. So we're going to tilt our axes 60 degrees, you see. Then we're going to find the standard form of that red ellipse, because it will be no longer tilted to our eyeballs. Okay, so it's very clever. That's the technique. Okay, so we need to tilt our axes 60 degrees, and everything will line up beautifully. We'll write the standard form, we'll be done. All right, it's going to be a bit of work, though, because when we tilt our axes, all the coordinates change. And they change according to these rules. X will now become x prime cos 60 minus y prime sine 60. And y will become x prime sine 60 plus y prime cos 60. Okay? Yeah, plus. So the x is the minus case, and the y is the plus case. Okay, so let's put in our cosine and sine of 360. So basically, x is going to become x prime times a half. So basically it's 1 half x prime minus root 3 over 2 y prime. And I learned a long time ago it's always a good idea to factor out that half. The y is very similar, except it's rad 3 over 2 x prime plus 1 half y prime. So again, we'll factor out the half, but it goes 2x prime plus y. I'm sorry, I meant to put rad 3 x prime plus y prime. Like I said, if you're tired of writing the little apostrophes, you can stop writing the little apostrophes. It's okay. Okay, so what are these guys? These are your new x and y. This is x, and this is y. You see? Those are going to be substituted into the original tilted bully equation. Okay? So life is going to get really messy for us. This x that I just highlighted is going to get substituted in twice. Once into the x squared and once into this xy. The y that I just highlighted is going to go in right here and right here. So that's a lot of substituting. Here's something I found to make my life easier. It turns out eventually I'm going to need to square. You can see that I'm going to need to square x and y. See that? That's part of the deal. I'm going to have to square x, I'm going to have to square y. I'm also going to need to eventually find an xy product at some point in time. So I've learned that that might be just worth doing first and get those answers all tidied up, and then I'll just plop them into the original yellow equation at the top. Okay? So I'm going to do a little bit of detour, like scratch work on the side here. I'm going to find x squared, I'm going to find y squared, I'm going to find xy, I'm going to get these guys ready to go. And then I'll substitute them in, bam, 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 into my original problem. Okay? All right, here we go. What is x squared going to be? Well, you're going to square that thing in green. So it's going to be 1/4. You're also going to have to do like x prime minus 3y, square root of 3y prime, and quantity squared. So it's going to look something like this. There's going to be a 1/4. Then since you're squaring x prime minus 3y prime, rad 3y prime, you're going to basically get like an a squared minus 2ab plus b squared sort of look. So it's going to look like this. X prime squared minus 2 rad 3 x prime y prime plus 3y prime squared. Okay, that's x squared. Let's do the same thing for y squared and xy. Y squared is almost exactly the same, except it's a 3x prime squared plus a 2 rad 3 x prime y prime plus a single y prime squared. So the coefficients are 1, negative 2 rad 3, and 3, and then on the y squared it's 3, 2 rad 3, and 1. Okay? Be careful that your y's look like y's. A lot of people write their y's real sloppy. this is one of those lessons where you can't afford that mistake. Make sure y's look like y's, or you'll be so lost. Okay, now we need to find x, y. That's just part of the original problem, you know. There's an x, y in the original problem. So let's just take care of that now. So I'm going to be multiplying these two greens together. So I'm going to take 1/2 of the half, obviously, so that's 1/4 again. And I'm multiplying the x prime minus 3 rad 3 y prime with the rad 3 x prime plus y prime. So it's like a foil. It's a foil. So I'm going to get first, outers, inners, last. So it's first is rad 3 x prime squared. Outers plus x prime y prime. Inners minus 3 x prime y prime. Lasts minus rad 3 y prime squared. And the middle two terms there are like terms. So you can actually, if you want to, put these two guys together. Put those two guys together. So obviously, I'm already running out of space. How you guys doing? You got some room there? Yeah. Okay. This is what I meant about using a big piece of paper. Make sure you use a big piece of paper for this. Okay, it's time to substitute all of this into our original. I need to erase my black there, my scratch word. Are you guys cool with me erasing that? You should have it on your paper already, so it shouldn't matter. Okay, Mr. Shor's going to erase this. Okay. So the yellow equation at the top of the board, I'll highlight in green, that thing up there, we have to write that now. So x squared was 1/4 x prime squared minus 2 rad 3 x prime y prime plus 3y prime squared. This is your old x squared. Okay. Then we have a plus rad 3 xy. So that's going to look like this now. Rad 3 x prime squared. I already collected my like terms. Minus 2x prime y prime minus rad 3 y prime squared. And then I also need a term that says 2y squared. So I need that guy. So that's going to be plus 2 times 1/4 3x prime squared plus 2 rad 3 x prime y prime plus y prime squared. And then there's a minus 10 equals 0. I'm just going to write equals 10. So I'll just write equals 10. I'll just move the 10 to the other side. Okay, that is our equation. Now you might say that is the ugliest thing I ever saw in my life. But watch this. The bully is now gone. The bully is now gone. Because we rotated our axes so that the graph's no longer tilted from our perspective. So this is so cool. If you guys don't mind, I'm going to erase all the 1/4. So I'm multiplying by 4. I'm going to erase all 1/4. And when it comes to that 10 right there, I'm going to make it a 40. So I'm thinking of this as 1/4 times 40. I'm just going to go through and erase all my 1/4. So this is going to become a 40. I'm basically multiplying everything by 10. And then that will give me a chance to get in here and clean this up. I'm just going to go in here, erase this 1/4, erase this 1/4, erase this 1/4. And then I made the right side 40. That was fair. I can do that. Multiply by 4. Okay, I also need to distribute the rad 3 and the 2 that are sitting out in front of their parentheses. So this needs to happen. Okay? All right, so Mr. Shore is going to go back to the top and use some of the space that he has up top. You guys are just going to have to make this work. I'm sorry. Okay, so now we have x prime squared minus 2 rad 3 x prime y prime plus 3y prime squared plus, I'm distributing the rad 3 now, 3x prime squared minus 2 rad 3x prime y prime minus 3y prime squared plus, now I'm distributing the 2, 6x prime squared plus 4 rad 3x prime y prime plus 2y prime squared equals 10. Wow. And the bully is gone. I must have made a mistake because some hands popped up. So let me catch my error with the help of this. Yes, video watchers probably caught it too. Mr. Short meant to write a 40 there. Thank you. Okay, so watch this. This is the cool part and the rewarding part because you know you did it right if this happens. If your bully disappears, you know you did this right. We've got a negative 2 rad 3 x prime y prime, another negative 2 rad 3 x prime y prime, and there's a positive 4x rad 3 x prime y prime. And that bully is gone. Okay, we can also go on to collect our like terms. Let's look at x prime squareds. For x prime squareds, we've got 1 of them here, another 3 of them here, and another 6 of them here. That's 10 of them. Let's look at our y prime squareds. There's 3 of them here, minus 3 of them here, so that's nothing. And then we have here two of them. So it turns out it's 2 y prime squareds that survived. If you're a little lost, it's okay. Just know that I made a substitution and it all cleaned up for me. You can go back and check it later. Wow, look at that. Divide by 40. You got yourself standard form. By far the most rewarding thing in the world for this class. So that is not complicated at all. That is what the ellipse equation looks like when we tilt our axes and line it up nicely with what the bully did. So it's like a bully who breaks your bike, right? He bends the wheel or whatever. Well, or maybe he tilts the wheel on your bike. Well, if you kind of turn your head, the amount he tilted it, things don't look so bad. It doesn't look bent anymore, right? He still bent your wheel. You have to get it fixed. But there's always a bright side, right? So somebody tilted our car, but we were willing to tilt our head and look at it again, and now no longer looks tilted, you see? So there's your equation. Let's talk about the equation now that we finally know what ellipse it is. By the way, it did turn out to be an ellipse, didn't it? You can tell from the standard form. So that first calculation we did, remember when you had the b squared minus 4ac? That was probably unnecessary because in the end you would have said, oh, that's an ellipse. Like you would have known anyway. Okay, so what kind of ellipse is it? Tall or wide? Tall, good. So it's a tilted tall. Right? Okay, let's draw a non-tilted. Let's see. It would be tall. What would be the a squared? A squared would be what? 20, and b squared would be what? 4. Okay, so that means that it would basically hit rad 20 on the y-axis and negative rad 20. And then it would hit negative 2 and positive 2 on the x-axis. And your ellipse would look something like this. Oh yeah, and the bully tilted it. How much did he tilt it by? 60 in the counterclockwise direction. So actual answer looks like this. This is the actual answer in the end. This is what the bully did to our graph. It was standing upright, he tilted it 60 degrees. He changed the equation. He made it harder for us to figure out what happened, but we sort of reverse engineered it and we figured out that was a 60-degree tilt. We even figured out the equation he tilted it. Like the equation he tilted. It's pretty cool. So this is extremely complicated, but this is what happens when you enter the world of rotation. It's so much harder than sliding left, right, up, and down. It's so much harder. It uses trig. It actually uses matrices. We can get into that. And you can see this is quite a nightmare. Can anyone think of why this problem, though, is on at least 2 levels considered to be very simple? I just did like the hardest problem you've ever seen, probably. And I'm asking you why, for 2 reasons why it's a simple problem. What could have made this so much worse? Excellent. If the center had not been 0, 0, this problem would have been way harder. Can you tell me why the example 4 here in the notes, how can you tell by looking at example 4 in the notes that this thing is not centered at the origin? You can tell by looking. see the clue? Let me pause recordings. So it would have been more complicated if angle's not special. Okay, so this is where we left off in class. Some of the periods I briefly discussed this problem, others I didn't, but let's start running through it. So the first thing we can do is identify that A is 4, B is negative 4, and C is 1. This tells me that my conic is going to be negative 4 squared minus 4 times 1. It turns out you got a discriminant 0, so that means this is a parabola. Parabola. Okay, so now we know it's a parabola. Let's write that up here. We're going to need all the space we can get, so I'm going to erase this work. We can also use the cot 2 theta equals A minus C over B to kind of figure out what theta is. Okay, this might get a little awkward, but in the end, we're really not that interested in theta itself. We're interested in cos thetas and sine thetas. So we're interested in x, which equals x prime cos minus y prime sine. And we're interested in y, which is x prime sine plus y prime cos. Okay? So if we can't find theta, we'll at least find cos theta and sine theta. Okay, so going back to this, we have 4 minus 1 over negative 4. So that's just simply negative 3/4. So you think, well, that's no big deal. My cotangent is negative 3/4. No big deal. Okay, well, first of all, this means that you're going to be very tempted to grab your calculator right now. But instead of doing that, let's draw a quick picture. Okay, so we know that 2 theta is always an angle between 0 and 180. So let's just draw that. We know it's quadrant 2 because we have a negative x over y ratio. So this means x over y when you're looking at your unit circle or whatever. So where the heck would it be? Well, it's definitely quadrant 2, and let's just use one of those triangles that we often use to kind of figure this stuff out. So we'll call this negative 3 and 4. So obviously it's a 3, 4, 5 triangle. Okay, so this is a graph of 2 theta. We really need theta, and ultimately we need cos theta and sine theta in the end, right? Okay, so I wonder if there's a way maybe we can find cos theta when all we know is the triangle for 2 theta. So there is an identity that relates double angles to single angles, and it looks like this. These are some old identities you might want to use. So we know that cosine 2 theta is 2 cosine squared theta minus 1. That's a true statement. We could substitute in negative 3/5 here, because we got that from our triangle. Look at the triangle. We know that cosine is negative 3/5, right? And that's for the 2 theta drawing. Okay, so that's what we're going to do. Okay, and then you're going to add the 1 over. Divide by 2. And square root. You're going to find that cosine theta is either plus or minus root 5 over 5. Now, theta, since 2 thetas in quadrant 2, we expect 1 theta, just theta, to be in quadrant 1. So I know that because if you divide an angle that's in quadrant 2 by 2, something that's between 90 and 180, divide by 2 is going to be between 45 and 90. So I'm expecting only positive cosine here. So Mr. Short is going to erase the plus minus. Again, I'm going to just assume that cos theta is rad 5 over 5. Rad 5 over 5. So I'm saying that this is a rad 5 over 5, and I'm saying that this is a rad 5 over 5. Okay, let's go now and see if we can find our sine theta. So it shouldn't be too hard. Let's see here. Oh, I know what we can do. There was another identity where this is a sine. Remember this one? 1 minus 2 sine squared. Okay, so let's play that same game. This time we'll use 1 minus 2 sine squared. Ooh, we're going to get our sine this way, see? So this time it's going to end a little differently. This time we're going to subtract the 1 over instead of add the 1 over. And we're going to get negative 8/5 equals negative 2 sine squared. Divide by negative 2 and square root. So sine is going to be basically plus or minus 2 root 5 over 5. We already declared theta as a quadrant 1 angle. So again, we'll ditch the plus minus, we'll just go with plus. So going back over here, we can see that each sine theta is going to be a 2 rad 5 over 5. Okay, so that's awkward, but that's what we have. The cosine is rad 5 over 5. The sine is 2 rad 5 over 5. Okay, so we never actually found theta. I think it's like 68 point something degrees, but we don't really need that. We just need the x and y that substitute out. Okay, so let's see what we got. So we've got x prime times root 5 over 5 minus y prime times 2 root 5 over 5. And this is x prime times 2 root 5 over 5 plus y prime 2 root 5 over 5. Okay, if we factor out the root 5 over 5, we basically get this. X prime minus 2y prime and 2x prime plus y prime. Okay, these guys are very important. They are your x and y substitutors. They are your x and y substitutors. Okay? All right, I'm going to erase a little bit now, and so I can kind of see what I'm doing. You can go back in the video if you need to jot those things down again. You'll notice that my equation is going to require an x squared and a y squared and an xy. Okay, so my x was, remember, root 5 over 5 times x prime minus 2y prime. And I'm squaring that. So when you square the rad 5 over 5, you get 1/5. And when you square the inside, you get x prime squared minus 4x prime y prime plus 4y prime squared. The y squared is very similar. It's root 5 over 5 times 2x prime plus y prime, and that's being squared. So again, you get a 1/5, but this time the coefficients go 4, 4, 1. Make sure your x's look like x's and your y's look like y's. It's really important for the sloppy writers, okay? We also need xy. So the xy is basically 1/5 times, I'm sorry, it's a root 5 over 5 x prime minus 2y prime times root 5 over 5 2x prime plus y prime. This is more of a FOIL situation. So you multiply the root 5 over 5 with the root 5 over 5, you get 1/5 again. And then you have 2x prime squared, that's outer. I'm sorry, that's first, I mean. Then we have outer and inner. The outer and inner is going to give me x prime y prime minus 4x prime y prime. So basically minus 3x prime y prime. And then the last gives me minus 2y prime squared. So at least that was clean looking. And there's no radicals in our x squared, y squared, and xy. Okay, now it's time to rebuild our conic equation using the ingredients here. All right, so I'm going to write that, this time replacing everything. Okay, so it's going to go like this. 4, instead of x squared, I'm going to write 1/5 x prime squared minus 4x prime y prime plus 4y prime squared. So this is the 4x squared right here, this first term I just wrote, that's 4x squared. So I think I'll do this, I'll do like a highlight as I go kind of thing. So that's the first part of the equation, and that's the first part of our modified equation. Okay, and then it says minus 4xy, so it's going to be minus 4 times the xy. Xy is right here. So it's going to be minus 4/5 2x prime squared minus 3x prime y prime minus 2y prime squared. So now I've got the first two terms. The equation's building, isn't it? Okay, next we're going to try to include the y squareds. The y squared, that's right up here. Already calculated that. So basically it's 1/5 times 4x prime squared plus 4x prime y prime plus y prime squared. So now Mr. Short is done with the first three terms. Okay, and then this gets interesting. The last problem we didn't have this extra linear term here, so I'll do this one in yellow. But our next term is 5 rad 5x. 5 rad 5x. So we have to do 5 rad 5x. Remember the x was root 5 over 5 x prime minus 2y? The x is on our page. It's actually right here. I stole that. Okay, so that's the yellow term. And then we have a plus 5 and the equals 0. So Mr. Shore, if you don't mind, Mr. Shore is going to take the plus 5 and move it to the other side. So I'm just going to write equals negative 5. Okay, this is pretty awful, but first thing I'm going to do is clean it up a little bit by going through and multiplying everything by 5. So I'm going to clear the fractions, basically. So I'll multiply this term by, whoops, that's not the marker I wanted. Hold on, I was going to use a green pen here. So I'm going to multiply this by 5. This, already here. This term by 5. So this cancels out. Multiply this term by 5. So this cancels out. Multiply this term by 5. So this cancels out. Multiply this term by 5. So that's interesting. It's actually going to cancel here. And then, of course, multiply the right side by 5. Okay, so let's see what we got. I'm going to erase the stuff at the top because I don't need this anymore. In fact, I'm going to write my next line of work above. So now I have a 4x prime squared minus 16x prime y prime plus 16y prime squared minus 8x prime squared plus 12x prime y prime plus 8y prime squared plus 4, and this is a 4, I know it looks like a 9, but that's a 4x prime squared. So plus 4x prime squared plus 4x prime y prime plus y prime squared plus, okay, and then the yellow term, this yellow term is 5 rad 5 rad 5, so that's just 25, so basically plus 25x prime minus 50y prime. Mr. Shore has already distributed everything, and I also remembered to multiply the right side by 5. So everything's properly distributed. It's time to see if the bully went away. So did the bully go away? Let's see. We have negative 16x prime y prime, and we have a 12x prime y prime, and another 4x prime y prime. I think the bully's gone. That adds up to 16x prime y prime, and you're taken away. Nice. Okay, let's collect our x squared. So we have 4 of them here, minus 8, plus another 4. I think the x squared term's vanished. I think our x squared term vanished. So, interesting. Let's look at our y's. I'll put triangles around them. There's 16 of them there, and 8 of them there, and another 1 there. That's 25 y prime squareds that survive that. We also have, for survivors, just a 25x prime, not squared, just 25x prime, and a minus 50y prime, and this equals to negative 25. Okay, because the bully canceled, I'm going to trust my work implicitly from this point on. I'm going to divide this resulting equation by 25 because it seems like everybody would be happy with that. So I get y prime squared plus 25x prime minus 2y prime equals negative 1. And if I bring the 25x to the other side and kind of get it out of my face, I can complete the square for the y's. This is not a prime. This should be a prime, not a square. So I'm going to subtract the 25x prime over the other side. Okay, so now I have basically y prime squared minus 2y prime equals negative 1 minus 25x prime. And I'm going to add my magic number to complete the square. So I'm going to add a 1 and a 1. On the left side, I get y prime minus 1 squared. And on the right side, since the 1's cancel, I just get negative. Mr. Shore made a big gross error. It's easy to fix, but go back. This is 25 over 25 is 1. So this right here should have been a 1, which means I'm actually subtracting 1x 25x. So Mr. Shore will fix it. This is a 1. So I'm sorry, there should not be a 25x that survives, but rather just an x that survives on the right, a negative x. Okay, man, can you believe how simple that thing is? It needs a prime. So this is our equation, you see, and it's very easy to graph. Let me clear out some of this scribble scratching up here. This is our conclusion, that this thing is just a sideways parabola with vertex 0, 1. So the vertex is 0, 1. Now this is in the x prime, y prime world, where things are rotated, but that's what we got. And it's just a sideways left-facing parabola. So at first you might just think, oh, it's just going to look like this, right? It's going to be, 0, 1. It's going to open to the left. Okay, just remember that you've got it drawn in XY version. That's wrong. These are x prime, y prime. And the x prime, y prime axes are actually tilted a certain amount. So if you want to, you can go ahead and get out your calculator now and go back to that cotan 2 theta equals negative 3/4 thing. Remember that? Or actually, even better, remember when we said that cosine theta is root 5 over 5? Now you could, if you wanted to, just kind of figure out what angle is that. So let's do that real quick, just so we can draw a nifty final drawing. Okay, so let's go in here and let's do inverse cosine of rad 5 over 5. Okay, that's in radians, because my calculator always goes back to radians, my emulator here. So multiply by 1 over 5. 63.435. 63.435. So why is it important? Well, I was planning on plotting it, so I kind of need to know that. I need to tilt these axes by that much. Okay, I need to tilt these axes by that much. Okay, so let's go draw it in a spot where I can actually rotate. This is my, sorry, Mr. Shore is going to clear the ink, clear the page. Okay, so here's what we had. If we go and draw our parabola like this, that's actually wrong because it's on the wrong axes. But now we can take this and turn it. Actually, Mr. Shore wants to do, how am I going to do this? I want to turn it fair and square. Let me try something else. Okay, so we have a parabola facing this way. It needs to be turned by, how many degrees was that? It was 63.435, right? 63.435. Okay, so you can kind of grab it and turn it about 60 degrees. Okay, and then when you plot your axes, just draw your y-axis like this. Call that 1. There we go. Okay, so this is what it looks like in tilted form. This is the y prime axis, this is the x prime axis. And then you can also put back your x and y axes. So x-axis goes straight across, y-axis goes straight down. There, I kind of was able to sketch it pretty nicely. You can also find all kinds of things here. You could find the focus point. If you wanted to, you could find the focus. Okay, for our last little thing, just for fun, let's find the focus. Okay, so it's actually not very hard. You know that this is the parabola. If you're looking in the red world, it's y prime minus 1 squared equals negative x prime. Okay, so this is of the form y minus k squared equals 4ax. In other words, the 4a is this negative 1 right here. So 4a is negative 1, a is 1/4. If you're thinking of a as just a distance, a is 1/4. So I shouldn't have included that in negative. I'll just make it 4a is 1, meaning a is 1/4. Okay, so one space away from the vertex, or 1/4 space away from the vertex is our focal line, focal point. So the coordinates, if you're giving this like x prime, y prime coordinates, it's just the point negative 1/4, comma 1. Negative 1/4, comma 1. But that's if you're totally ignoring the red axes and you're just, ignoring the black axis, and just looking at the red axis. So imagine if you just totally ignore, can I just delete red axes? Yeah. Tilt your head. You see what I mean? It's negative 1/4 up 1. Okay? So now I'd like to get the xy coordinates. So don't stress out. We actually know already that x was root 5 over 5x prime minus 2 root 5 over 5y prime. Remember that? And we knew that y was root 5 over 5, 2 root 5. I don't know why I'm writing it this way. Mr. Shore shouldn't be writing this way. I had a nicer way to write this, remember? Remember when we wrote x was basically rad 5 over 5 x prime minus 2y prime, right? And then y, we wrote that as rad 5 over 5, and then it was 2x prime plus y prime. Okay, we can just use that. We'll just substitute in these two red numbers into this situation. Okay? So just reminding you what we're doing. We're trying to substitute in these two yellow numbers into here to get the xy coordinates of our vertex. All right. So how do we do that? Well, plug it in. So plug in negative 1/4 and 1. So if we make this a negative 1/4 and make this a 1, we have negative 1/4 minus 2, which is negative 9/4. So you have root 5 over 5 times negative 9/4. In other words, it's negative 9 rad 5 over 20. Negative 9 rad 5 over 20. Okay, then we go down here and we do the same thing. We plug in the negative 1/4 and the 1. So now you have negative 2/4 plus 1, or negative 1/2 plus 1. So it's just a half. So this is just root 5 over 10. So it's basically root 5 over 5, see, times 1/2. So it's root 5 over 10. The stylus doesn't work very well on the edges of my screen. So it's root 5 over 10. There we go. These are the x and y coordinates. So if you go back to the x-axis, y-axis, see, and you ignore the two yellow numbers here, just erase those, you could label, in fact, you could even erase the axes, the x prime, y prime axes. Let's just erase those real quick. Kind of distracting right now. Just erase the red axes. Go back to the traditional xy axes here. Oops. Black pen. There we go. Okay, so what are the coordinates of this floating focus? The fly in the fly trap, the flower in the vase, the fruit in the bowl. What is that thing? The coordinates of that thing. Well, if you're doing x prime, y prime, we said it's negative 1/4, 1. But if you're thinking xy, it's negative 9 rad 5 over 20, comma rad 5 over 10. So slightly left, slightly up. Makes sense. You could also find the equation of the directrix and that sort of thing. I know this is a very long video, but the last example really is pretty much optional.